The recording begins with silence. Not metaphorical silence, literal, measurable absence. A handheld Brule and Chair precision sound meter rests on the concrete floor of an 8 by 12-foot cell at the United States Penitentiary, Administrative Maximum Facility, ADX Florence. The display wavers between 23.6 and 24.1 decibels. The sound of the human body itself. Pulse in the ear, breath turbulence in the nasal cavity, registers louder than the room. The engineer's field log notes. Acoustic environment comparable to an anechoic test chamber. Reflections. Negligible. Reverberation time, RT60, is almost equal to 0.18 s at 1 kHz. He removes his headphones. The hum of distant HVAC seems to vanish the instant he notices it. The walls do not echo, they absorb. Even his own exhalation dies inches from his mouth. The narrator asks, if a prison is built to erase the sound of its inhabitants, what kind of civilization builds it? ADX Florence was never designed to be loud. It was designed to be stable. When the Bureau of Prisons commissioned its construction in the early 1990s, stability meant predictability, no riots, no communication, no resonance. The Bureau's design brief used a phrase that has since become architectural folklore. Environmental control is behavioral control. That principle guided everything from air velocity to wall composition. Today, ADX stands as the quietest penal environment on Earth. The silence is not incidental. It is engineered. This documentary will show how acoustic design, the same science used to refine concert halls and laboratories, was inverted to serve isolation as governance. Through the lens of sound engineering, we will examine how materials, geometry, and mechanical systems merge into a single psychological instrument. Silence as compliance. In 1983, the murders of 2 federal officers inside the U.S. Penitentiary Marion triggered a doctrinal shift in corrections. Marion went into permanent lockdown. 11 years later, the Bureau demanded a purpose-built successor, a facility that could contain not merely violence, but communication itself. The contract went to Helmuth Obata plus Kassebaum, HOK, a firm more accustomed to airports and corporate campuses than to isolation blocks. Their directive: create a prison immune to disturbance, a structure whose very acoustics discouraged unrest. Internal memoranda from the period, later cited in BOP Design File 94 ADX, describe the goal in bureaucratic understatement. Reduce incidental sound transmission between individual housing units to eliminate inmate-to-inmate communication. The acoustic consultant on record recommended high-density concrete masonry with an STC rating greater than or equal to 60. For comparison, a luxury hotel wall rates around 55. The engineers exceeded the brief. Each cell became a sealed acoustic cavity. Walls: 2 layers of 8-inch reinforced concrete separated by rigid insulation. Total STC is almost equal to 63. Doors: double gasket steel with threshold sweep seals. Air ducts: sound traps using perforated baffles lined with mineral wool, NRC 0.95. Floors/ceilings: poured-in-place slab with epoxy coating, minimal resonance under 80 Hz. Every frequency band associated with human speech, 250 to 4000 Hz, is absorbed or scattered before it can cross the threshold. The result: communication range is almost equal to 0 meters. The blueprint reveals corridors that bend at oblique angles, not for aesthetics but for acoustic diffraction. A straight hallway transmits vibration like a flute. A segmented one dissipates it. Cells are arranged in pods of 12 around a triangular core. Each pod's shared wall angles 6 degrees off parallel, breaking standing waves that could amplify footsteps or speech. The ceiling height, 8 feet 9 inches, was fixed after scale model reverberation tests determined that a taller cell produced perceptible echo at 500 Hz. Even the toilets serve dual purpose. Vacuum flush units reduce hydraulic resonance that might travel between cells. An internal engineering note from 1993 concludes, acoustic modeling complete. Target background noise less than or equal to 25 dB. Objective: neutral auditory environment. Neutral is an imprecise word. In psychoacoustics, neutrality often equals deprivation. ADX's designers treated every surface as an interface with behavior. The smoother the surface, the fewer opportunities for inmates to manipulate it into instruments of sound. No metal grates that could clang rhythmically. No vent covers that rattle. Concrete fixtures instead of movable furniture, eliminating secondary resonance. Acoustical consultant R. M. Parsons wrote in his 1994 summary, "The facility shall produce a constant, low-amplitude background environment to inhibit the exchange of unregulated audio stimuli." Translation: background nothingness replaces conversation. In standard architecture, silence is a luxury. In ADX, it is a weaponized resource, rationed and absolute. Complete silence is not sustainable. The brain hallucinates sound when starved of it. To prevent this, designers introduced mechanical masking noise, the faint broadband hum of ventilation at 20 to 25 dB. An engineer described it as the sonic equivalent of fog. It obscures distant movements, equalizes atmosphere, and reinforces the sense of enclosure. In laboratory terms, it stabilizes the acoustic environment. In human terms, it ensures that inmates hear only themselves. 5. Institutional rationale. The Bureau justified these measures under the doctrine of operational security via environmental design. The official narrative claimed silence prevented coded communication through pipes and vents, an issue documented at Marion and Leavenworth. But internal performance evaluations tell another story. A 1999 BOP report observed, reduced auditory stimuli correlated with measurable declines in disciplinary incidents within the control unit. The system worked not by reforming conduct but by extinguishing expression. Independent acoustic testing in 2003 by the Federal Facilities Laboratory recorded an average ambient noise level of 24.8 dB in occupied cells, rising to 26 dB when the ventilation system cycled. The report compared the result to the anechoic chamber at Bell Labs, which measures 23 dB. A correctional officer interviewed for the study noted, "When you walk those ranges, you can hear your own boots scrape. The quiet is physical. Feels like pressure. Sound here is not absent. It is inverted, felt through the body rather than heard through the air." By 2005, ADX's acoustic model had become a reference for other federal control units. Design manuals cite ADX-derived environmental criteria without acknowledging their psychological consequences. The same principles appear in later facilities, the Communications Management Units, CMUs, in Terre Haute and Marion, scaled down but conceptually identical, contain thought by containing sound. Early behavior tracking data from ADX's first decade revealed an unintended outcome. Staff noted that long-term inmates began speaking in shorter phrases, lowering their voices even during monitored interactions. A 2001 BOP psychological bulletin labeled this adaptation self-attenuation response. Essentially, the environment trains silence. The Bureau interpreted this as compliance. Psychologists interpreted it as erosion of social cognition. Architectural historian Marianne Crawford later wrote, "ADX Florence represents the first penal structure in which sound itself becomes contraband. Unlike Foucault's panopticon, which relied on visibility, ADX relies on inaudibility. The absence of resonance becomes proof of order." This philosophical shift redefines punishment, not through spectacle, but through acoustic invisibility. By the end of its design phase, ADX had achieved what no other prison attempted, a controlled acoustic ecology. Every footstep, every breath, every word has been mathematically anticipated. The architecture does not merely resist sound, it consumes it. In this silence, governance becomes effortless. Communication, the raw material of rebellion, empathy, and identity, evaporates before it forms. And so, within the concrete harmonics of Florence, Colorado, the United States constructed a paradox. A facility so quiet that its success cannot be heard. Within ADX Florence, sound is neither accidental nor ambient. It is managed. Every cubic meter of the facility functions as a controlled acoustic system whose parameters were calculated long before its first inmate arrived. Where ordinary architecture begins with sightlines, ADX begins with transmission loss. Each wall, door, and duct is analyzed as a potential vector for vibration. Every vibration is considered a form of communication, and every communication is considered a breach. Thus, silence at ADX is not an absence. It is an administrative outcome. The entire prison breathes through a mechanical network known internally as the environmental control pathway. Air does not move freely between cells. It passes through individualized duct segments lined with fiberglass baffles set at alternating angles to break wave propagation. Each segment's attenuation index averages 25 dB per meter at 1 kHz. By the time any sound has traveled one full duct length, it is effectively zeroed out. Even maintenance staff describe the effect as directionless flow. Air exists, but its source cannot be located by ear. This acoustic uncertainty prevents the simplest form of inmate contact, the shouted word. The medium that carries life also carries isolation. A constant low-frequency hum, typically between 60 and 120 Hz, amplitude less than 25 decibels, fills the background. To a visitor, it seems trivial, a barely audible murmur. To an engineer, it is a form of white noise masking, a deliberate saturation of the environment to cover residual vibrations. In an open-plan office, such masking improves concentration. In a closed concrete cell, it becomes the baseline reality. The sound is continuous. It has no beginning, no end, no identifiable source. Over time, the human auditory system stops registering it as sound and begins to treat it as the texture of existence. The Bureau of Prisons refers to this condition as environmental equilibrium. Each cell door at ADX is a 4-inch composite assembly of solid steel and acoustic insulation foam. The door seals are dual-lipped silicone gaskets rated for sound transmission class 57. When the electronic lock engages, a pneumatic compression mechanism forces the door into full contact with the jamb, eliminating the tiny air gaps that normally transmit high-frequency resonance. The effect is not simply quiet, it is total spatial separation. Guards refer to this as hard silence. The door does not only block voices, it erases presence. The only audible cues that remain are mechanical, the click of the lock, the controlled hiss of the air system. Both are signals of control, not of life. The walls and ceilings are coated with an epoxy compound containing microscopic silica aggregates. Its noise reduction coefficient, NRC, measures around 0.8, unusually high for a hard finish. In testing chambers, such surfaces absorb nearly all mid-range frequencies, leaving no echo above 250 Hz. Consequently, footsteps, speech, and movement produce no return feedback. A person inside the cell hears themselves, but nothing returns from the environment. Architecturally, this prevents acoustic buildup. Psychologically, it removes the sensory boundary that defines self against space. The corridors of ADX are built not as straight tunnels but as segmented sequences offset at irregular angles of 7 degrees to 11 degrees. This design disrupts sound propagation in the mid-range human voice frequencies. Security rationale. Sound waves traveling down a corridor lose 90% of their amplitude within the first segment. Operational outcome. Voices cannot carry between pods. Footsteps vanish after 10 meters. Each angle is therefore a behavioral barrier, an architectural translation of policy. Even the furniture is part of the acoustic network. Each bed frame and desk is cast into the wall and floor, creating what engineers call vibration dead ends. The absence of metal fasteners or hollow tubing removes any internal cavities that could resonate. When maintenance workers perform repairs, they use torque-limited tools to prevent residual vibration. The same procedures appear in laboratory cleanroom design. Here, they ensure that a raised voice cannot travel through the structure itself. Every sensory environment has a threshold. Below roughly 30 decibels, human perception begins compensating. At ADX, prolonged exposure to levels under 25 dB produces measurable adaptation. In medical literature, such adaptation manifests as heightened internal auditory awareness, hearing one's own heartbeat or blood flow, time perception distortion, reduced speech amplitude when communication resumes, The Bureau's internal wellness reports document these responses clinically, noting increased introspection and low verbal output as positive indicators of adjustment. Within the logic of the institution, silence is success. The same silence that isolates also enables observation. Microphone sensors embedded in certain corridors record aberrant noise patterns, impacts, raised voices, metal contact. Because the baseline sound level is so low, even the smallest deviation registers sharply in the system's analytics. Guards do not need to hear. They monitor data. The architecture therefore inverts the usual relationship between sound and power. The prisoner is deaf, but the institution is hyperauditory. In environments with constant low noise and no dynamic range, time perception shifts. Acoustic psychologists describe this as temporal compression, the subjective shortening or blending of hours due to a lack of auditory events. Within ADX, days pass with identical sonic profiles. No bells, no external cues, no footsteps in the hall to mark shift changes. The only variable sound is the mechanical cycle of the ventilation system, repeating every 15 minutes. The facility thus operates as a clock without time, where routine exists only as regulation. Silence changes behavior, and behavior reinforces silence. An inmate moving quietly to avoid attracting attention generates less noise. The system interprets that as improved compliance. Reduced incidents lead to fewer interventions, which maintains the acoustic equilibrium. From a management standpoint, the facility appears stable. From an environmental standpoint, it is a closed loop of self-reinforcing quiet. Stability here is indistinguishable from suppression. Outside the prison context, anechoic chambers used for research impose strict exposure limits, typically 15 minutes, before subjects experience sensory disorientation. ADX imposes it indefinitely. Architectural analysis confirms that the cell acoustics differ from research chambers only in minor reverberation residuals, almost equals 0.2 SRT60. Functionally, the experience is parallel. A person enclosed within an acoustic null. Where laboratories record hallucinations and anxiety as experimental anomalies, ADX records them as environmental adaptation. Official bureau language never refers to silence. Documents use phrases like controlled acoustic environment, low stimulus design, and reduced auditory exchange. The terminology converts a sensory condition into a management tool. Silence becomes data. Compliance becomes a metric. In this semantic framework, the human experience of sound is irrelevant. Only its administrative function matters. Maintaining the silence is a continuous technical task. Engineers inspect seals quarterly. HVAC ducts are cleaned with non-metallic brushes to prevent scratching that might alter noise profiles. Any mechanical fault loud enough to register audibly triggers a service ticket marked Priority 1. A sound event above 45 dB inside a pod, roughly the level of a quiet conversation, is considered an operational anomaly. Most are caused by maintenance tools, rarely by people. The system, in effect, polices itself. Control at ADX does not depend on constant supervision. It depends on predictable physics. Once the sound field is stabilized, every deviation signals disorder, and disorder can be immediately corrected. Thus, the architecture performs surveillance automatically. It listens without listening. The mechanism of silence operates on three intertwined levels. Physical, materials and geometry absorb sound. Mechanical, air and masking maintain consistent background equilibrium. Administrative, data from the silent environment guides behavioral policy. Together, they form a self-sustaining infrastructure where silence is both symptom and strategy. The facility's success cannot be measured by noise reduction alone. It is measured by the continuity of that reduction over years. ADX's acoustic environment is therefore not a byproduct of architecture. It is its central nervous system, a soundproof feedback machine converting physics into compliance. After nearly 3 decades of continuous function, ADX Florence presents an almost perfect data profile. Incident rates low, response times predictable, maintenance noise within tolerance. Within institutional analytics, such uniformity reads as success. In reality, it is evidence of a closed acoustic feedback loop, a system in which control and silence reinforce each other until both become indistinguishable. Each subsystem, HVAC, door compression, surveillance, feeds live readings into a centralized building automation system. The software correlates mechanical noise, inmate movement, and security alerts. The quieter the readings, the higher the compliance index. Noise itself has become a diagnostic sign of disorder. In correctional management literature, ADX Florence appears as a case study in passive control design. Traditional facilities rely on active enforcement, verbal commands, alarms, kinetic restraint. ADX achieves compliance through environmental determinism, the condition in which architecture, not authority, governs behavior. The Bureau's internal summaries describe this outcome in mathematical terms. One report defines inmate management as a stable function of environmental constants under variable psychological conditions. In that formula, silence is the constant. Silence does not affect inmates alone. Correctional officers operating in sustained low-noise environments show measurable behavioral changes. Shift logs reveal reduced verbal communication between staff. Orders are transmitted via hand signals or short codes entered on terminals. Speech itself becomes operational overhead. The absence of ambient sound amplifies minor noises, a key turning, a radio click, making them disproportionately intrusive. To maintain equilibrium, personnel unconsciously lower volume and pace. Over time, the entire staff develops a form of institutional whisper. In effect, the architecture trains everyone inside its perimeter. Sound cues orient perception. When those cues vanish, distance and duration collapse. Inside ADX, this produces a condition psychologists term auditory narrowing. The brain reduces attention to external space and amplifies internal processing. Measured indicators include slower reaction times, monotone vocal range, and difficulty recalling temporal sequences. Routine assessments conducted under the Special Housing Unit Evaluation Protocol list these features as environmental normalization. The implication is clear. Adaptation equals success, even when the adaptation erases ordinary perception. Because the environment yields little audible information, the institution substitutes data. Every motion sensor ping, every temperature shift, every air pressure reading functions as a kind of artificial soundscape, a continuous digital murmur. Operators monitor graphs instead of noise. To those trained within the system, the absence of alarm sounds safe. In this way, silence acquires meaning, a data-encoded reassurance that the architecture is obeying itself. Periodic reviews by contract psychologists note that subjects exhibit flattened effect and reduced verbal initiative after long exposure to low stimulation cells. These findings are cataloged as expected adjustment patterns. The reports do not recommend change. They classify the outcomes as operationally advantageous. Language within these documents is exact but impersonal. Sustained environmental control promotes self-directed regulation. The phrase conceals its mechanism, sensory monotony prompting inward withdrawal. Yet within the Bureau's metrics, withdrawal equals stability. Because the facility's baseline is near silent, any audible disturbance becomes an immediate signal. The smallest metallic impact propagates through sensors as an anomaly triggering localized lockdown. This response loop operates faster than verbal command could. Consequently, the mere possibility of sound becomes deterrent. Inmates internalize the cost of audibility. What emerges is an acoustic economy. Speech is risk, stillness is currency. Time within ADX is measured less by clocks than by recurring acoustic events generated by machinery, air handling cycles, door seals, inspection trolleys. These intervals are uniform across years, producing a steady rhythm that functions as an institutional heartbeat. The Bureau refers to this as predictive temporal structuring. Its goal: reduce uncertainty by ensuring each mechanical noise occurs at a calculable moment. Yet the result is perceptual drift, an environment where identical sound signatures erase the distinction between yesterday and today. The maintenance department keeps detailed acoustic calibration logs. Every service cycle includes decibel verification at 3 frequencies: 125 Hz, 1 kHz, 4 kHz. Deviation greater than plus or minus 2 dB triggers corrective work. In no other federal building is silence itself treated as infrastructure requiring calibration. Here, quiet is both goal and asset, maintained like electricity or water pressure. The governing philosophy of ADX Florence can be summarized as control through predictability. Predictability depends on removing variables, and sound is the most volatile variable in human environments. Where sight can be blocked by walls, sound escapes. Therefore, silence becomes synonymous with containment. This logic transforms architecture into ideology. To prevent chaos, remove resonance. To prevent conspiracy, remove conversation. To prevent disturbance, remove difference. What remains is a uniform acoustic field, a managed nothingness. In comparative audits between ADX and standard high-security institutions, the Bureau lists 3 quantitative advantages. Metric, standard USP, ADX Florence. Average daily incident noise greater than 45 dB. 14 events. 1 event. Disciplinary reports per 100 inmates. 22. 5. Maintenance noise deviations. 9 per month. 1 per quarter. The table demonstrates the system's efficiency. However, the metrics measure silence, not welfare. No column records the cost of absence. Over time, the institution begins to view silence not merely as a condition but as virtue. Operational handbooks equate quiet units with effective units. Training materials encourage staff to maintain environmental calm. Thus, the acoustic design evolves into an ethical one. Sound equals disorder. Quiet equals moral order. In this equation, a perfectly silent facility becomes the ideal prison, an ideal that can never acknowledge its own human subjects. Every complex system develops emergent behaviors not foreseen by its designers. At ADX, the emergent property is acoustic self-regulation. Inmates move less, speak less, act less. Staff intervene less. The infrastructure adjusts less. Each component's stability reinforces every other. The building becomes an organism whose metabolism is silence. The Bureau interprets this as optimization. An engineer might call it thermal equilibrium. A sociologist might call it stasis. The influence of ADX extends beyond its walls. Blueprints for subsequent federal communication management units replicate portions of its acoustic schema. High STC cell partitions, offset corridors, controlled white noise masking. The same specifications now appear in juvenile isolation units and psychiatric observation cells. Silence has become an exportable technology of control, a design language detached from its original purpose, applied wherever predictability is desired. In engineering documentation, failure is defined by measurable deviation. Because silence produces no measurable deviation, it conceals its own consequences. A system that registers only noise cannot detect suffering. From the perspective of its sensors, nothing is wrong. This structural blindness ensures endurance. As long as the readings stay quiet, the institution perceives itself as humane. Independent oversight groups occasionally conduct acoustic tests during inspections. Findings are reported in careful language. Facility maintains exceptionally low ambient sound levels consistent with design intent. The phrase closes the loop. Oversight confirms the condition the design set out to create. No further inquiry is requested. Silence thereby becomes self-legitimating. The architectural silence of ADX mirrors a wider cultural preference for order without noise. Societies equate calm with control, productivity with focus, efficiency with quiet. In that sense, ADX is not an anomaly but a magnified reflection. The endpoint of a civilization that confuses tranquility with justice. From a strictly technical perspective, ADX Florence can be defined as a closed acoustic feedback environment optimized for minimal stochastic disturbance, yielding maximum behavioral predictability among confined subjects. Every word in that sentence is precise. None are moral. The design achieves its goal flawlessly. Whether that goal should exist remains outside the document's scope. After 30 years, the facility continues to operate within design parameters. Ambient noise averages 24 dB/A. Annual incident rate remains below 0.1 per inmate. From an engineering standpoint, the system has reached terminal equilibrium, a state where no further adjustment is necessary because every variable is already controlled. Equilibrium, in physics, often precedes entropy. In institutions, it becomes permanence. Silence is engineered through architecture. Silence conditions behavior. Behavioral stability validates the architecture. Validation ensures the preservation of silence. The mechanism requires no intervention, no ideology, no visible coercion. The building enforces itself through the physics of quiet. Across 3 decades of observation, the evidence remains internally consistent. The acoustic environment of ADX Florence functions as an intentional instrument of behavioral management. Material analysis shows that every surface, duct, and mechanical assembly is calibrated to restrict vibration. Operational data confirms that silence correlates with compliance. Psychological monitoring demonstrates adaptation to low-stimulus conditions. In technical terms, the design is flawless. In human terms, its perfection is the problem. According to the Bureau's Performance Index, the success of the step-down, the control unit, and the entire institution can be summarized in one number. Ambient noise less than or equal to 25 dB/A. Within this range, order is absolute. Disturbance is inaudible. Any deviation above threshold constitutes disruption of equilibrium. The logic is simple. Silence equals safety. Safety equals compliance. Compliance equals rehabilitation. The loop closes with an equation that requires no moral variable. Justice systems traditionally operate through visibility, trials, witnesses, public record. ADX operates through inaudibility. Where ordinary courts broadcast sentences, this architecture executes them in quiet. In the absence of sound, documentation becomes the only form of testimony. Every incident, every reaction, every silence is archived as data. In the record, noise appears only as error codes. Thus, the prison converts punishment into process, process into metrics, and metrics into validation. Its moral language is measured in decibels. The endurance of this model lies in its apparent neutrality. Silence is not politically charged. It carries no image, no spectacle, no protest. It is therefore sustainable. When budgets are reviewed, acoustic control is described as maintenance cost, not ideology. When audits occur, inspectors confirm design compliance, not existential consequence. The system survives because it presents itself as engineering rather than philosophy. Modern architecture often claims to humanize institutions through transparency, light, openness, connection. ADX represents the inverse thesis, that control requires opacity, density, and the erasure of resonance. Its designers achieved an acoustic inversion of the civic ideal. Where civic space amplifies voice, this space neutralizes it. Where public architecture aspires to dialogue, this one enforces monologue, the building speaking to itself in the hum of machines. The influence of ADX's acoustic logic extends beyond prisons. Elements of its design, sound-absorptive panels, controlled masking, behavioral acoustics, appear in corporate offices, data centers, even educational facilities marketed as focus environments. Each iteration claims efficiency, calm, productivity. Each repeats the premise that the absence of noise equals order. The moral distance between a silent office and a silent cell is vast, yet the design vocabulary is shared. Silence, however, resists full quantification. Sound meters record amplitude, not meaning. A perfectly quiet room can contain infinite distress or complete peace. Instruments cannot distinguish them. This limitation defines the boundary of the forensic approach itself. An auditor can describe what happens to decibels, not to conscience. Within ADX, that boundary is structural. It ensures that the institution will always appear successful to those measuring it. From an ethical standpoint, the architecture of ADX Florence demonstrates the capacity of technical disciplines to serve moral abstraction. Acoustic science here performs precisely as requested. The responsibility for what that precision achieves lies elsewhere. In academic language, one might call this the moral displacement of expertise, when knowledge fulfills its function so perfectly that it erases awareness of purpose. The silence is therefore collective, a collaboration between design and administration, intention and obedience. Across history, systems of confinement have evolved from physical restraint to psychological regulation. Chains became walls. Walls became surveillance. Surveillance became silence. Each stage refines control by reducing visibility of coercion. ADX represents the terminus of that evolution, a facility where control has no sound, no spectacle, and therefore no witness. If one defines civilization by its acoustic landscape, by what it allows to be heard, then ADX Florence represents a civilization that has optimized away uncertainty. Every decibel subtracted from its corridors subtracts a fragment of unpredictability from human life. Yet unpredictability is also the medium of dialogue, dissent, and empathy. Without it, order becomes tautology, quiet because it is quiet. From the outside, the prison seems efficient. From the inside, efficiency becomes indistinguishable from absence. As of the latest Bureau of Prisons report, ADX continues to operate within design specifications. Noise levels remain constant. Incidents remain minimal. The architecture remains unchanged. There is no malfunction to repair, no sound to fix, no crisis to report. Only the continuation of equilibrium, a perfect stillness maintained by design and defined as success. In acoustics, the point at which a reverberation decays below audibility is called the noise floor. Everything beneath it exists but cannot be measured. ADX Florence has institutionalized that principle. Its walls hold what lies beneath the threshold of hearing and beneath the threshold of policy. The sound of nothing has become the soundtrack of control. Silence can be a sanctuary, or it can be a sentence. In Florence, Colorado, it is both an architecture that listens by refusing to echo. This has been shadow of justices. The search for truth continues.